develop programs, little instruction codes that I can use and I don't have to rewrite myself. So I'm borrowing a few instruction codes here to allow myself to do it. The first thing here creates a variable in working memory called data frame, or DF for data frame, and it just reads in the file. So it takes a Excel file, or a CSV in this case, a comma-separated value file, and converts it into working memory in this thing called DF. Okay? When I actually run this code, it creates an image. I can click on it and actually see my spreadsheet. Okay? I can see everything that's in it. Okay? The next bit of code here is a little bit tricky. When I say df equals, what I'm doing is I'm actually rewriting the df that I just created in the previous step. Okay? And then I'm referring to it, I'm using it as the source, so it's both the destination and the source. And what I'm doing is I'm using the mutate function from dplyr, and I'm calculating a new variable called log score, which is the log of my variable q plus 1. Okay? What that does is, if you take bioanalysis, you know that one of your assumptions in statistics is that you have a normal distribution. Okay? I don't have a normal distribution. When I don't have a normal distribution, I have a skewed distribution, what do I do to my data? I transform it. One of my transformations is a log transformation. That's what I've done. I've created a new variable called log score, which is the log transformation of my variable q. Okay? Q stands for, this is important to write down, Q stands for your score on the particular question I asked you to email. Okay? So it's your score on that question, question 17 or question 15, whichever one you have to report to. Okay? So that's all Q is. Anytime you see Q, it's referring to your raw score for that question. Okay? The next thing I'm doing is creating a new data frame 2. I'm very creative in my names. Okay? That tells it to drop NA. Drop NA says, read the data frame, DF, find every row that has an NA in it somewhere, and delete it. Okay? So my data frame DF has 128 rows. My new data frame DF2 is going to have 108 rows. I'm going to lose 20 rows. Okay? Why? Well, because some of you didn't take the fluid intelligence test because you joined lab late. Some of you didn't email me your scores, so I don't have a Q for you, right? If I don't have a Q and I don't have a fluid intelligence, I can't include you in the model, so I'm cleaning up my data. A very simple command, get rid of all that stuff, okay? Then I'm selecting the variables that I care about. I'm selecting Q, fluid intelligence, exam score, and I'm running making a correlation matrix on that thing. Core, data frame 2, that's what we just created, and it creates a correlation matrix between these three things. Q is 100% correlated to Q. Well, that's a surprise, it's itself. It's like, how genetically similar are you to yourself? Well, you're 100% similar to yourself, right? But if I were to say, how similar are you to your parents, what would that be? So you would have an R squared value here of 0.5, okay? So how related is fluid intelligence to how well you did on that question? Well, about 16%, okay? How related is your exam total, how well you did on the exam overall, to how well you did on Q? Well, about 79%, okay? So those are highly correlated with each other. How well related is fluid intelligence to exam score? Only about 13%. And that's exam score. So exam is exam score, Q is question score. Okay? So fluid intelligence, of course, fluid int is probably what? Your intelligence score that you got on the first day. Okay? So that's my correlation matrix. Notice that I have this diagonal line of ones, and that everything is mirrored to the other side of that diagonal line. So I don't need to read, I don't care about these scores up here because they're just a mirror image of these scores down here. They're the same thing. Okay? So I only care about the stuff below the line. Okay, because you guys are used to like statistical tests, I wanted to calculate some p-values. So I looked at the whether this is significantly correlated to fluid intelligence, and it looks like it is not significantly related. My p-value here is not significantly related. There's no, yeah, it's not significant, okay? So it looks like there's enough randomness in my data that random chance might have produced the relationship I see of 15%, okay? I wanted to do for the thing that had high correlation value, exam score to Q, okay? This DF2 dollar sign just means take the from the data frame 2, take column exam and correlate it to data frame 2 column Q. Dollar sign just means I only care about this variable. Okay? And that's just because I have to specify, I have to give it an X and a Y, right? So I can't hand it the whole data frame because the whole data frame had 3 things in it. There's an X, a Y, and a Z. It can't do that. Right? It doesn't know what X and Y is. So I have to tell it what X and Y is. Okay? Are they significantly correlated? What's my alpha? My 0.05, right?
Yeah.
0.05 is my value, my alpha value. Is this less than 0.05?
Yeah.
Yes, it's way less than 0.05. So these are highly correlated with each other. Okay? Okay, now I'm going to create a quick new data frame where all I'm doing is dropping NAs. Okay? I'm going to do it from my original after I calculate my log score. Okay? Now I'm going to start to visualize my data. Visualization is my next step. Okay? So I'm going to create a box plot. That's this. This is a box plot. And I'm going to specify that I want my x-axis to be group. That would be whether you were group A or group B, right? Could talk or could not talk. Okay? And I want to see y is fluid intelligence. Basically what I'm going to compare is there a difference in fluid intelligence between the group that could talk or the group that couldn't talk? And I would expect to find what? I would hope to find no relationship. I don't want there to be a difference based on this. If there was a difference based on this, that would be a problem. It would mean that my sampling effort was biased. Okay? So I expect to see box plots that overlap strongly, and my notches here overlap almost completely, and my medians are almost exactly the same. Okay? Meaning that there's no significant difference between them. If you were in group A, the median fluid intelligence was just above 50, headed towards 60. And if you were in group B, it was above 50, but not quite as close to 60 as group A was. But no significant difference. Okay? Now I'm going to create another box plot, and I'm going to look to see whether groups perform differently on Q. Okay? This would begin to answer my question, right? I wanted to know whether people who were able to communicate about their concept map did better than people who had to do it in isolation. Is making a concept map a group activity beneficial? So if it's beneficial, I would predict to see what? That my box plots don't overlap. The solid portion of my box plots overlap and the medians aren't close to each other, okay? Or my notches don't overlap specifically, okay? So if I scroll down, do my notches overlap? Do the boxes overlap? Are the medians close together? Yeah, they're pretty close. Look, the median score for group A was 100. Almost everyone in group A, the most common score in group A was 100. Okay? The most common score in group B was a little less than 100, but still close to 100. Look, I'm somewhere up here. Okay? So what does that tell me about my groups? Whether you could talk or not talk doesn't seem to matter. I don't have any support in my data to show that there's a significant difference. It looks like chance is probably going to be able to account for the differences I'm seeing. Okay? So, I'm not hopeful that any stats I run is going to find a p-value of less than 0.05 here. In fact, I predict it's not going to be anywhere close to 0.05. Okay? We're going to see if that prediction holds true. All right, I also, though, it doesn't tell me whether concept maps were useful or not, right? This just tells me whether communication in the process of making a concept map was useful, and we don't see a signal here. Okay, so now I'm going to go on to the next box plot. Okay, another box plot. You see box plot listed there. Here I'm going to have grouping again, and now I want to see whether exam scores were different between groups. Given that Q wasn't different and Q was highly correlated with exam, what do I expect to find here? No difference. In fact, I wouldn't really want to see a difference, because that would mean that somehow I ended up with really good test takers in one group and really bad test takers in the other group. Okay? And that's what I see. I don't see a strong difference, and I also see that overall the performance in class was pretty good, right? The median score is somewhere close to 90. Okay? So a lot of people did really well on exam 1. Okay? That's the most common score, was to do pretty well. This is not the mean score, it's the median score, the most common score. Okay? Now what would it be if we did this for exam 2? Okay? It wasn't pretty. Okay, now I'm going to look at, I'm going to make what point here means that I'm going to make a scatter plot. Okay? And I'm going to do two things. I'm going to make a scatter plot looking at the relationship between fluid intelligence and Q. Based on my correlation, what would I expect to see? Not a strong relationship between the two, right? It wasn't significant, but there was a positive correlation between the two. It was about 15%, right? Okay, so I would expect to see a slope going up, that as fluid intelligence increases, Q score increases, but I would expect it to be non-significant. How am I going to test for significance? I'm going to do it indirectly by doing this method equals LM. I'm creating a linear model of X on Y. Okay, very simple linear model. And this allows me to create 95% confidence intervals around my line, my trend line. Okay? The rule is that for 95% confidence intervals, if I can draw a line that is flat in the shaded region, it's not significant. If my shaded region allows me to draw a flat line, I don't have a significant interaction or relationship here. Okay? So let's look at our graph. Can I draw a flat line in the shaded region? So is it going to be significantly different? No. No. Yes?
When I draw a flat line, do you mean across the entire graph?
Yes. So if I go from here, the shaded region allows me to draw a flat line and still remain within all points on that line fall within the shaded region. Okay? Let's look at the next one, where we do the exact same thing, but we look between the relationship between exam and Q, and we already knew that that was a significantly correlated relationship. Can I draw a flat line here and it remain within the shaded region? No. So it's significantly different. Okay? That means for any value of question whatever score, I would be able to positively predict exam score or vice versa. Okay? In this case, I made my dependent variable question score and my predictor variable exam. It doesn't really matter. Okay, I can switch those and it would keep the same relationship. Okay? All right, now I'm going to look at exam to fluid intelligence. Remember, our correlation was 0.13. And given that our correlation of 0.15 wasn't significant, I also think I'm not going to find anything significant here. Okay? And can I draw a flat line? I can easily draw a flat line. It's not significantly different. Okay? So these begin to help me to tell the story. With the box plots and my point scatter plots here with my trend lines, I can begin to say whether I'm having effects between my variables or not. I go on, though, to make a linear model. This LM stands for linear model. My equation is right here. Okay? I want to know whether the log of my Q score, remember, the log score was, we did a mutate function earlier on. We calculated log score as the log of Q plus 1. Okay? The reason why we had to do the log of Q plus 1 is because if we have anybody get a 0 on Q, the log of 0 is not intelligible, and it ends up giving me an NA. Okay? And remember, when I clean my NAs, I remove that row, right? So I would lose extra data that I don't have to lose, because a score of 0 is a real data point. Okay? So if I do log of 0 plus 1, now the log of 1 is what? 0. So my score, my log score value is actually going to be 0. I'm going to retain my score, but I will be able to log transfer everything else around that 0 and not lose that value. Okay? So I maintain my data. That's why I did the log of Q plus 1. Okay? It's just a neat little trick. Okay? Here's my equation. Does group or fluid intelligence predict my log score? Okay? Summary mod means give me my summary of my model. Mod just stands for model. Remember, DF stands for data frame. I'm just making shorthand so I don't have to type out data frame every time I want to call it. Okay? So here's my results. What I care about is two-part. I'm going to do something I didn't do for the first group. It's going to be bad for them, but anyway, we'll see. Okay? Anytime you do a model where you have more than one independent variable, you are going to have two levels of statistics. You have what we call an omnibus test. Do you know what an omnibus means? Omnibus means everybody get on board. Okay? Omnibus means everything included. So this p-value down here, this stuff down here, is my omnibus result. So is the total model significant? Is my total model significant? No. Generally, I can stop there, right? But we can go on and get a little bit more useful information. So in an omnibus test, I would report my F statistic, which is this first number here. Here's my F statistic. Here's my degrees of freedom. I have 2 degrees of freedom, 2 and 105. Why 2 and 105? How many rows did I say occurred in this data frame? 108. I went from 128 in my original data frame. Once I removed NAs, I went to 108. Okay? The degrees of freedom are the number of variables minus 1. Okay? So I went 3 minus 1. Okay? To 2. And my error degrees of freedom are my number of observations minus my number of variables. So 108 minus 3 to get me to 105. Okay? So we call this my degrees of freedom and my error degrees of freedom. Okay? So that's why I have 2 values. And then I have my p-value, which you're already used to. There's my p-value. Okay. Now what else would I want to know? It's helpful to the value of a linear model, and you're going to do this in bioanalysis once you get to the end of the semester. You're going to run a linear model. The value of a linear model is in the estimate here. Okay? But this also gives me my t statistic and my p-value. I would report these 3 numbers: the estimate, the t, and the p-value. And I would report them in this order: T, P, estimate. T, P, estimate. Toilet paper estimate. Okay? TP estimate, that's my order. Okay? Just like I would report my F is F, degrees of freedom, P. Okay? This is in the bio writing guide, and the bio writing guide is on eClass. Okay? The instructions are on eClass on how to report this stuff. There's a section for linear models. You do this. Okay? We just covered it though. I'm going to now interpret the numbers. Okay? This is where it gets tricksy. What does a p-value measure? It gives me some measure of the likelihood that my data can be explained by chance. the p-value is 1, what does that mean? Chance is the best explanation of my data. Okay? If my p-value is 0.05, what does that mean? In only 5% of cases would I expect to find the values I saw between my variables by chance. Okay? 0.05 is not magic. It's just an agreed upon convention. It doesn't mean anything special, right? So in this case, what is the probability that I would find the difference I saw between group A and group B by chance? I would expect to see it most often by chance. Chance is a really good explainer of the differences I saw. Okay? So group B is really well explained by chance. I fail to reject my null hypothesis. Okay? What is the probability that chance can explain my relationship between fluid intelligence and log of score, or log of Q? It's still about 20%, right? So nowhere near as well explained as group is, but still not strongly, I haven't ruled out chance enough to be confident to say it's not chance. Right? That's what you're really saying with this p-value. Okay? Remember, this is reflected in the slope that we see here. Is there a linear relationship between fluid intelligence and Q-score? There's a weak linear relationship, but it's not significant. Why is it not significant? I can draw a flat line. Okay? So I can't rule chance out, but there's a hint of a relationship. Okay? Now, we talked about previously that p-value is not sufficient by itself. I don't want to end at p-value. The thing that I also want to add to p-value is effect size. The estimate is a measure of effect. When the value is linear, when I'm talking about a continuous variable against a continuous variable, what I'm really saying with the estimate is, for every increase in fluid intelligence, I would expect an increase of 0.03 in my Q-score. Actually, my log of my Q-score. Okay? So not very big, right? Not very big. Is it having an effect? Maybe. There's one more thing that I want you to show you. It's this. This is my confidence intervals around my estimate. The very last table is a confidence intervals around my estimate. Okay? So I am 95% sure that if I were to measure this 1,000,000 times, I would find an estimate between these numbers. Okay? So it could be as big as, for every unit increase in fluid intelligence, I see a 0.007 increase in my log of Q, or I actually see a decrease in my log of Q. Okay? That's why it's not significant. If my confidence intervals for my estimates are on both sides of 0, right, positive and negative, it's not significant. If it's significant, they should be on one side or the other. Okay? So not only is this again showing me that it's not significant, it's also showing the magnitude of the difference. If fluid intelligence were significant, my data do not suggest it's very significant. It's not important. Not just very significant, it's not important, right? So think about it this way. This goes back to our paper. They had pedagogical implications. Here's a pedagogical implication. Okay, I'm about to interpret this pedagogically. Okay? If I had to advise a student what was the best use of their time, I would not, based on our data, advise them to work on their fluid intelligence. I would advise them to make a concept map and just study that concept. Okay? Now let me ask you this. Was the concept map helpful? Why or why not? Can our data tell us anything about whether the concept map was helpful or not? No, why not? Both groups had a concept map. Okay? Only the difference between Q and exam, if you didn't make a concept map anywhere else on the exam, but for some reason you did really well on Q but not anywhere else, that would be evidence that concept maps were beneficial. Is there any reason to believe that? There's some weak reason to believe that, right? Remember that we said the average for Q was really, really high, right? Both groups had 90s or better as the median score for Q, okay? But neither group had a 90 for exam, which means the total exam was less than the Q, okay? When you made a concept map, students did better, okay? However, it's possible that Q was just a really easy question. And so it didn't discriminate the effect of a concept map. I can't answer that. Our data don't allow us to answer that. We can't conclude anything about that. So we could say future research should, and give a suggestion here, because we see a little hint that a concept map was beneficial to the students, because students did better on Q than they did on average on the other questions. But it could be that Q was not discriminatory. We don't know why it wasn't discriminatory. We know it wasn't discriminatory. We don't know why it wasn't discriminatory. Okay? So do you understand that the p-value does not tell me by itself whether I should recommend, because imagine, let's play with the numbers here. Imagine this value was 5. And our confidence intervals went from negative 0.001 to 5. Okay? That would mean that the vast majority of our data support a positive effect of fluid intelligence. But I had too much variance to make it significant. Maybe I didn't have a large enough sample size. Okay? But I have pretty good evidence suggesting that there's something here that I should follow up on. So should I pedagogically recommend that you work on your fluid intelligence? Well, if it could go up to 5, then maybe yes, right? Maybe that's a good use of your time. But ours does not do that, right? If there was an effect, it would have been a very weak effect. So it's not worth our time, right? Because remember, sample size can make me find something that is not very useful is significantly different because of sample size, okay? The bigger my sample size is, the smaller of an effect I can detect. So my sample size would have to be huge here to detect this small of a difference, okay? So I have to be careful. That's why some papers, they make their alpha 0.001 instead of 0.05, because they have a really massive p-value. So they don't, like I said, they have a really massive sample size, so they want to decrease their p-value to make it harder to find significance. So they're not confusing insignificant, like non-meaningful things as meaningful. Okay? All right, I've covered the results. These graphs here you do not need. They were for me to evaluate how well my model fit. They're about model fit. You don't need to know them. You're not going to report them to anyone. Don't worry about those. Okay, they were for me. But everything else in here you could potentially use, but you don't necessarily have to use, right? I am not recommending, in fact, I will specifically not recommend that you use every graph in here. I don't think that's a good idea at all, okay? But you need to decide which graphs help you tell your story, okay? So you have to know what story you're trying to tell, okay? All right, I'm done showing you the results, telling you what you need to report, and helping you to interpret the results. This is the last time I'm going to do it, so what questions do you have for me? After this moment, you will be doing it on your own. By on your own, I mean you can talk to each other, I just won't be directing you on this. You can talk to me and ask me questions, but I will not tell you what to do. I will just help you, I will ask you a question back. We're going to be doing the, what's it called? The Platonic the Socratic method. We're going to be doing the Socratic method. You ask me a question, I will reframe that question in a helpful way back at you, and you will answer that question. Okay? Yes, and then yes.
Will we need to know how to code like that?
No. You do not need to know how to code, it's just the way that I run my stats. So since I need to show you the stats, I did it, right? In fact, if you wanted to, you could just go hide, 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 hide. There, I like that. Hide that. Hide this. Hide that. Hide this. Right, look at that. Oh, beautiful. Beautiful, beautiful. You can do all of this on the file I gave you. It's on eClass now. You can click hide and it will hide it. It's on eClass. You will have it. It's already there. It's on eClass already. Just look under the README section. Okay, yes? Okay. Okay, saw a hand in the back, and then we'll come forward.
So am I understanding we're all going to individually make a poster, and then one poster is going to go to a meeting? Or was the
No.
meeting all made
We're not going to meet. This is just practice.
Oh, okay.
We ain't going anywhere with this. Okay. Okay, you will, to answer your question directly now, you will make a poster for yourself. Okay? Everyone will upload their own poster. However, you can talk to each other about this stuff, right? You can work in somewhat groups of things. I don't recommend everyone trying to do whatever, but you are going to do your poster. Okay? You are uploading your own poster with your name on it. No, not today. I didn't say when it was due. I just said you will do it, right? That's going to be the assignment. Okay? Now, a couple things. Let's go to eClass. Actually, here it is. Yes. Let me show you a couple things on eClass. I'll get to you in a second. Why is there so much chatter? I'm going to show you some things. Okay? Here's our lab space. Okay? Here you have a turn it in. And for the concept map, you will have something else. So I will put a turn it in box. Actually, it already is right here. Poster turn in. Okay? So that's where you will upload your assignment. I will fill that in with information like due dates and all that other stuff in a little bit. Okay? Here it says PPT poster template. Okay? You're going to make a digital poster, and you can use any service you want to do it. I've provided you one with a template from PowerPoint. The PowerPoint is a custom slide that would print to 3 foot by 4 foot. Okay? So it's, that's a standard size poster for a scientific conference. It's already in that format. It's already in landscape. Okay, do we know what landscape is? Portrait landscape. Okay? So it's 4 foot by 3 foot. Okay? If you want to rotate it and put it in portrait, that's fine. You don't have to make a landscape poster. Okay? This is bare bones. It just gives you a text box. It gives you a template to work from. You can change it in any way that you want to. You can use Canva to make you can use Prezi to make your stuff. Okay? There are other services besides PowerPoint. I'm just adding one of them for you. Okay? So, and you have the results. Fluid, int, and concept map NB. That's exactly what we've just been looking at here. It's all of this information. Okay? Including the code. All of the shows. Okay? Hide all code. Okay? Okay? So, when will this be due? Okay, again, I'll put it online a little bit. I'm assigning it today. You can begin working on it right away because we've gone over the interpretation. Okay? You then have the rest of this week. You have spring break. Our next class period in lab will just be working on the poster. We will do nothing else but that. I won't be talking at all. You will show up and do what you want to do. Okay? It will be due before the next class period after that. Okay? So when I said you have 3 weeks, I'm serious. You have 3 weeks to do this assignment. That's lots and lots of time to make very bad decisions. Okay? The very best decision you can make would be try to hammer out a poster immediately, before spring break. Okay? Throw together as much as you can right away. Because when you come back for the next actual lab, you show me what you've done, and I help you work through. Oh, I would change this, I'd change this, I'd change this, right? If you begin working on it at that date, I ain't doing anything for you because I cannot do anything for you, right? Okay? So you make your own decision. You're an adult, but I won't, I'm just telling you what is the smart thing to do. Okay?
So, what percentage of our posters should be based on results, and how much of the methods and other stuff should be covered?
You are telling a story just like this is telling a story. Okay? You're just doing it in a poster format. Okay? I would caution you, one more word of caution where I'll show you something. I would caution you. So if I look up research science poster, okay? If I look at these things, show more images or whatever, okay? I hate them. Okay? Why? Man, I want to run screaming because it's like, oh, look at the work. Oh. Okay? So most of the examples you're going to find online, I don't recommend following. Okay? But there are some good guidelines online. You just need to figure out your searches to figure out what you want to do. So look for a lot of stuff, but don't trust that just a straight Google search of something as simple as this is going to get you very far. Because most people, literally, all they do is take a paper, separate out all the sections, and put it on a poster. That's not a great idea for the reasons we talked about earlier. Yes? It was because our distribution, there are assumptions in statistics. One of the assumptions is that your distribution is normal. We did not have a normal distribution. Right? No, that has nothing to do with it. Where were you getting that from? Let's correct your notes. Yes, that is what we mean by normal, but it doesn't specify what your value has to be. Normal doesn't mean from -1 to 1. It just means that it is bell-shaped. Yes. So that's a standard assumption for statistics, is that your distribution of your data is normally distributed. If you don't meet that assumption, you have 2 options. Either you have to run a non-parametric test, or you have to transform your data to make it normal. I chose to transform my data to make it normal. So that was the purpose of the law. Okay? I knew from the moment I started to enter scores for Q into the gradebook, not the gradebook, into our Excel spreadsheet, that this was not going to be significant. And I could tell that I was going to have a highly skewed, right? My skew was going to be like this. How do you know it's skewed? You saw the box plots, right? The medians are super high on the box plot, right? And they're near 100%. But most people are getting hundreds on this question. It's not going to tell us anything, right? So I have to do something. I have to stretch my distribution out because it was really bunched up over here, and I have to stretch it out by log transform. Okay, yes? Or, nope. Nope. I don't like rubrics. I like for you to make your own decisions and to act as a professional. Professionals don't have rubrics that you work from. You have to go from goals to process, right? That's what this assignment is about. What are your goals? What are you trying to accomplish? That's how I begin to make decisions about things. I don't make the decisions for you. A rubric just encourages you to shut your mind off and follow instructions. That's not what we're doing. Okay? Yes. No, you, Sprouse.
Should it flow in the way you're talking about, you should be able to present this, but then also read it as a paper, or?
You're gonna have to answer that question for yourself, right? We're telling a story. What's gonna be the most effective communication? What am I trying to communicate? So you have the Socratic method at work here?
You said this is kind of where I won't.
No, I'm not going to do the assignment for you, right? I cannot answer certain questions because it then says, oh, all I have to do is this. No, that's not what we're doing. You're telling a story. You have to try to understand like what the story you're trying to tell and why you would make certain decisions and not others, right? So I can help you work through like what's the story you're trying to tell, but I can't tell you what the story you're trying to tell is, right? So that's the difference between why I have to switch from sometimes being able to directly answer and sometimes having to use a Socratic method because I cannot answer certain questions to accomplish the assignment. We'll go back and we'll come forward. Yeah. No, you can title whatever you want. No, there's no surprise. Right? Is it effective? Right? Do you tell a clear story? Right? Yeah. Is it professional in appearance? Right? Is it something that wants me to make me run screaming for the hills, or is it something that I would want to engage with? Right? So I'm evaluating exactly the stuff that we talked about when we were evaluating this paper, and we were talking about communication. Those are the things that I'm looking for in the poster. That's what we are grading. Now we do have a rubric. I'm just not giving it to you because it encourages you to only do the things that are on the rubric as though it's a checklist. That is not this assignment. You have to make your own decisions. Okay? So I've just told you what's on the rubric though, right? I'm looking for clarity, I'm looking for accuracy, I'm looking for presentation, I'm looking for whether your story is complete or not. Okay? Those are the things that we're looking for. Okay? But they're the things that you're looking for in anything. Okay, yes. The what? So assume that you are going to a real conference. Your audience is educated, but not necessarily interested, right? So I don't assume that they know every jargon term you know, right? Make it accessible for them because again, at a real conference, there's enough variation in what people do at that conference to make jargon an issue, right? So when I go to conferences, I have people who do systematics and like biogeography and paleontology. That's not what I do. I do behavior, right? So we have to, we live in different worlds. We're all biologists, we're all studying the same type of organism, but we're studying different aspects about them. We're all knowledgeable, everyone's got a PhD or is really, really smart, is working on one, but we don't all know each other's disciplines. So I have to balance being explicit enough with not being patronizing. Okay? Yes? Yeah, our independent variables are fluid intelligence and group. And group was whether you could discuss as you made your concept map or whether you were supposed to do it in isolation. Okay? Those are our independent variables. Our dependent variable was Q, how you scored on that question, right? The question that was specifically about the thing we made a concept map of. Exam score was just because we were wondering about, remember, I wanted to know, is this question easy? Like, is there a reason to think that? So that's a secondary thing that I threw in later. It's not really part of the original setup. Okay? Yes?
Are you going to actually present this to you, or are you just...
No, you're going to put it online. This, remember, I said, this assignment, what we're doing right now is practicing for the final. This is the practice. I said I would show you and talk about every aspect of what you're supposed to do. Now you're going to try to do it. Okay? And you're going to try to do it where I give you feedback before I actually have to grade you as though it's your final. Okay? So the goal of this assignment is to make to do it as well as we can, but to figure out mistakes and problems now so that they don't show up on the final. Okay? This is a safe environment to explore. Yeah?
You said that the degrees of freedom are like the independent variable -1?
Don't worry about it, just report them.
Okay.
It's in the bio writing guide. And the bio writing guide is on eClass. In fact, if I go back to here, I should be able to find the bio writing guide. There it is, right there, biology writing guide. Okay? If you are in doubt about what you should report, there is a section of the bio writing guide called linear model. Do that. Okay? Ben.
It's like so.
There's no requirements for the sample size. I mean, like in a real study, there's not a requirement. There's good practice. Do you want a power analysis? I mean, I can run a power analysis if that's what you want. It's up to you. If that's what you want to report, just come see me and I'll tell you what the power analysis is. Power is your ability to detect how well you're able to detect a difference if a difference exists, right? So your ideal power is like 95% power. 95 is a good thing, right? No. We got 95% confidence intervals. And you're gonna hear 95 a whole bunch of times. Power would tell you how likely was I to find a difference. Okay? If we have really poor power, you're like, oh, well, I mean, there should be a signal here. Because remember in our results, what's our p-value for fluid intelligence? It was 0.2, right? Our scatter plot shows a linear relationship, right? Our scatter plot supports the idea that as fluid intelligence increases, Q increases, right? But there's too much noise in the data, okay? If I had more data, I might see the confidence intervals become tighter, okay? In which case, I could detect a very small difference, right? I just don't know. Is there really a difference here? Just because I fail to reject the null hypothesis, where I think chance can account for my data, and I'm not confident, doesn't mean that the truth is that there is no difference, that fluid intelligence doesn't matter, right? So I'm using several lines of reasoning to suggest that fluid intelligence, while it shows a relationship, looks like it's not really an important relationship. That was our 95% confidence intervals at the very end. Because even though they straddle 0, they're very close to 0, right? They were 0.007 and negative 0.002. So they're not fluctuating very much. So even if it was significant, it doesn't look like it matters, right? So imagine it like this. Let's say that I was developing a new drug to treat diabetes, and the drug costs $100 for a refill, but only improves outcomes for my patients by 0.001%. Should I recommend it to my patient? Doesn't, right? The improvement, while significant, does not justify the cost, right? That's the relationship that we were trying to get at between the last table confidence intervals around my estimate and the p-value in my model summary. Okay? All right, any other questions? Because you cannot just you don't just go off of p-values. You have to make this more coherent, more well-supported argument for why you're interpreting things one way or the other. Okay, yes?
So it's like layout of like this, like poster, and not like an experimental layout, or you like an introduction?
You can do that. So remember, you're telling a complete story, right? And we already said that you want to have a complete story so that anybody looking at your poster, even if you weren't present, would be able to know the complete story, right? You don't have to be there, but they could know it. But does that mean that I have to put it all on the poster? Or can I make it available in another way, right? So do I need an introduction? Do I need a method to tell a complete story? I do. But do they have to be on the poster? How do I put them on the poster? Those are open questions. Okay? That's where, again, if you ask follow-up questions to what I just said, where I'm going to have to start to use the Socratic method. Because it's going to depend on what story are you telling. Okay? Yeah.
So,
We'll go to Dixon next.
overall, depends on whether you recognize and plastic.
You're talking about the overall conclusion of the study? Yeah, so there's like 3 different levels here, and some of the things we tested and didn't test. Do we have any evidence to suggest concept maps work? We've got some. It's not clear, we've got some. Do we think that working in community or working in isolation matters? We see no strong link between those things. Do we think fluid intelligence matters? There's weak evidence for it, but it's not clear. Right? It's a summary of our conclusions. Okay, Dixon.
Can you show us an example of a good research poster?
You know, beauty's in the eye of the beholder here. So I don't, to find one, I'd have to search for one. And I don't want to spend that much time doing it. But I would say, what would make a good one? I would try to balance ease of understanding, ease of storytelling, with having all the information available. I definitely don't want to put all my stuff on a poster just in blocks of text. Okay? Because while it's all present, you accomplish the first goal, it's not very easy to look at, it's not very pleasing to look at, it's not very welcoming. So how do I do this? Okay?
Thank you.
That's the challenge. Okay, any other questions? Okay, I have office hours for the rest of the week except Friday, because Friday's new school. I don't have any office hours next week. I'll have normal office hours on the following week when you still have an opportunity to work on it. I'm sick, so if you don't want to get sick, you maybe don't want to close yourself in a room with me.